notes with you. I want all the students to join the session. Okay. Can you see the information what I'm displaying? Please reply yes or no.
Yes, ma'am.
Yes, okay, good. Thank you for the reply. So in unit 1, we have covered till addition, subtraction, multiplication, division. And today we are going to cover floating point representation. Very simple, very easy concept. Okay, before going for what is floating point representation, what is the main content under unit 2? What you have analyzed? Why we have to learn this topic under computer architecture? Arithmetic for computers. Anybody can reply to the question? Why are we learning these concepts under this unit? Unit 2, arithmetic for computers. What is the purpose of learning this unit topics? Just reply. Why we are learning computer architectures? Computer architecture subject. It's a software related subject or a hardware related subject? Please reply. Whatever you know, just reply. Don't be ideal. Reply, students. See, we being human, we are able to do whatever we know the basic concept of math from our school life. We know the calculation of addition, subtraction, multiplication, division, all those things. So if you're going to fit the knowledge to the computer where it have to perform addition, subtraction, multiplication, division, or whatever floating point values you're going to give inside your system, it will have to be calculated properly. Okay. So for that, what are the things we have to know? We have to know how a binary addition is performed, how a binary subtraction is performed, how a system will do binary multiplication, binary division. Why we are using the term binary? Because the machine understandable language is the low level language which represent in the 2-bit zeros and ones. So we are dealing all those information in binary form. Say yes or no. Reply yes or no.
Yes, ma'am.
Yes. Okay, I'll admit. So as we have covered all types of long divisions, multiplication, values, how it is going to be performed, now we have to go for the floating point representation. In general, what is the meaning of floating point? Anybody can tell? What are the numbers comes under the topic floating point? Please reply. What is a floating point numbers? In C program, you use a data type called float. What did it represent? Please reply.
Decimal or fractional value, ma'am.
Very good, very good. Decimal numbers you can say, or fractional, or you can say exponential, all comes under floating point numbers, real numbers. Okay, good. So before going for the real concept of PPT, we'll go for some example. So just ஒரு notes மாதிரி note பண்ணிருக்கேன். You also kindly get the information and note in your notebooks. Okay. So what is a simple information you have to know? Is able to see the information what I am displaying? Say yes or no?
Yes, ma'am.
Yes. Okay. Floating point representation, we have to make use of some standard. So standard for representing a floating point in the case of 32-bit and 64-bit. That only we are going to cover in the topic floating point representation. So which is being developed by IEEE. What is IEEE? Institute of Electrical and Electronic Engineers. They have framed a particular format where it can be used for a floating point hardware inside a system. If you are making use of a 32-bit processor, then this one type of standard have to be followed. If you're using 64-bit, then you have to use a double precision. And the ரெண்டு concept இருக்கு. Try to understand. When you are coming across a floating point representation concept, we have to know the standard way of representing in a IEEE format. So what is the standard way of representing this? If your processor is a 32-bit processor, then we will follow a single precision format. And if it is a 64-bit, we have to follow double precision. Okay, இது ரெண்டும் நீங்க ஞாபகம் வச்சுக்கணும். So this is single precision, double precision. So what are the bits under the single precision? 32-bit. Double precision 64. So what is a particular format we have to follow in a single precision? இது வந்து சும்மா hint மாதிரி நோட் பண்ணிக்கோங்க. The real concept and information I will show in the PPT. Okay. So in single precision, what is the format they have followed? The IEEE format. So the particular 32-bit is represented here. 32-bit has been splitted into fractional number, exponential number, and yes for a particular sign number. If is a positive number and a negative number, we have to allot a space for it. So how it has been represented? It has started from 0 to 31. You know the range for a 32-bit representation. And how it has been, the field given inside the format, fraction is given first, exponent, then followed by sign bit. Yes. So for a sign bit representation, how much of bit you have to allot? 1 bit. Exponent na 8 bit. Fraction 23 bit. Kindly note it. This is a single precision format. Okay, single precision format. They will ask a question. They will give a they may give a floating point number for you, and you have to convert that floating point number. So that will be in the decimal form. It have to be converted to its binary form, and you have to place that binary value in this format. So we have to know the information of what a single precision format, what is a double precision format. Got the point? So single precision, what is the field involved? Yes, for sign bit, exponent value have to be placed here, fractional value, and for each and every field, how much of bit is allotted? 1 bit, 8 bit for exponent, and 23 bit for fraction. And how the values are represented? 0 and 31. So from 0 to 22, fractional value, from 23 to 30, exponent, and last is 31. Did you note the single precision format? Reply yes or no?
Yes, ma'am.
Thank you. So double precision. Now double precision, what is the double precision format? It is a support of 64-bit. So how we have to represent the field in the case of double precision? Again, same sign bit is allotted for one field, exponent, fraction. Fraction is also called as mantissa. Okay, its other name is mantissa. So for double precision, what are the field? Yes, 1 bit is allotted, exponent 11 bit. So you want to know the difference between a single precision and double precision. For exponent 8 bit is given, for here 11 bit is given. Just wait students, I'll admit a student. Okay. Next one you have to remember is, after knowing what is single precision format and double precision format, how much of bit is allotted for each and every field? Fraction 20 bit, exponent 11 bit, for sign bit 1 bit. Now here if you have noted in depth, they have mentioned E dash, here also E dash. So exponential is represented like this. So for finding this value, இப்போ வந்து நம்மளுக்கு கொடுக்குற floating point value, it will be large enough to be replaced within this bit. In that case, we have to do biasing அப்படின்னு ஒரு கான்செப்ட் வரும். What is that biasing concept? I will explain. Just note down how we have to do biasing. புரிஞ்சுக்கோங்க, எப்பவுமே ஒரு floating point number they have given and you have to convert it into its binary form, and you have to place that binary form representation within this bit represented in a single format or precision or double precision, we have to do some biasing. So biasing எப்படி பண்ணுவோம்னா exponential value வந்து just note like this, e dash equal to e, the real exponential value plus biasing. Bias value differ for single precision. We have, we'll see in the next biasing. இதை நோட் பண்ணிட்டீங்களா? இது வரைக்கும் நோட் பண்ணிட்டீங்களா? How to
Yes, ma'am.
how to do yes, e complement equal to e plus biasing. So for single precision we have a bias value, for a double precision we have a bias value. What is that? We'll see. So bias is a number you have to add for both single and double precisions. So what is that value? For single precision we have to add 127. Kindly note down. We have to add 127. For double precision, we have to add 1023. எதுக்கு இந்த values add பண்ணுவோம்? We will explain you later. For a 32-bit, we have to add a BIOS value of 127. For a 64-bit, we have to add a BIOS value of 1023. Okay. Did you note this information, students? So when you are doing a biasing for a single precision exponential value and for a double precision exponential value, we have to follow this too. What is a particular value have to be added? For a single precision, it is 127 plus the exponential real value of any question asked to you. Second case, 1023 have to be added in the case of double precision. Did you note this? Say yes or no?
Yes, ma'am.
Yes, thank you. Now we'll go for a real example. So for you, if they have given any floating point value, so you all know decimal point value, whole integer value, real values, whole numbers, real numbers, natural numbers, all comes under real numbers under natural whole numbers, fractional, exponential, all comes under floating point values. So here the given example for you is a floating point number where 1460.125 the base 10 is given. Now our duty is to convert this particular floating point value into its both single precision value and a double precision value. So how to convert the number in a binary format? First, a given decimal number have to be converted to its binary form because machine can understand only its binary format. How you have converted? இது உங்களுக்கு தெரியும்ல, நார்மல் நம்பர் சிஸ்டம் படிச்சிருக்கீங்க இல்லையா? Say yes or no?
Yes, ma'am.
Covered numbers. Yes, good. So all try converting this number to a binary now immediately, and then just cross check with this value. Now do, and then cross check with this value. Maybe some few students would have forgot the concept of converting a decimal number to its binary form. I'll just show this example for you. This is some other floating point value. Okay. Just for reference you can use. How you will normally convert the first digit values? For example 127.125 the value is given to you. This is easy for you to do. 127 with the LCM method. L method solvang liya. Just divided by 2, what is the value you give? From most least significant to most significant we have to place the similarly. Method reference காக நான் வச்சிருக்கேன். And the point after the value have to be found like this. 0.125 into 2, 0.250 you'll get. Did you remember this method? After the point, decimal point, we have to consider what value? -1, -2, -3. Kindly convert the given decimal floating point value to a binary form and cross check with this value. Did you all get this value? All got this value? Take your time. Again, I will show another one example so that if some people are feeling very difficult to convert a decimal number to a binary form. Can you see the information what I am displaying? Please reply.
Yes, ma'am.
Yes. You will find like this the value. So remaining will be put like this 1. And how you have to represent the value from top to bottom 001 001 and place in this value for 0.125. So any number you have to first convert 10.16. You have to convert now first 10 divided by 2 panni LCM method you can find the remaining value. 0.16 we have to do into 2 into 2. Okay. Reply that all got this value for 1460.125. So how you normally put 1460? How you do? 2. The value you will get.
730, ma'am.
Just like that you have to proceed. Good. Like this you have to proceed. 2 3s are 6, then remaining 2 6 are 12, then again 10, 5 2 10, 0. Like that you have to proceed. So I'll just set a sample thing. Then what value you are getting, you have to replace this. This you have to do for 1460. They all are trying that value, pa? Then you have to find for 0.125 into 2. How you will do? How you will get it? First value 0.250 you got after multiplying by 2. Say yes or no?
Yes, ma'am.
Yes, good. Whether you have to proceed. Simple down. Already known information. Into 2 you have to do what value you will get? 5 2 are 10, 1, 5, 2.0. All got this answer. Next you have to proceed with 0.50 into 2. Again you have to do 0.05.0. All got this answer, students. Please reply yes or no. Then at last you will get what? 0, again 0, 1 you got. So how you have to put this value? Yes. So all got this value, students?
Yes, ma'am.
Please reply yes or no. Yes,
Yes, ma'am.
okay. But with this value, you can't frame this value inside a single precision format or double precision format. So what you have to do, we have to normalize this value. How we have to normalize this value? By putting this exponential value. So you know point value inga irukku. So how you have to shift that point value? The other way of representation. 1 2 3 4 5 6 7 8 9 10. Point இங்க போட்டுட்டு 1.000 into 10 2 to the power 10. Any doubt with this? This is how we have to do normalization. Good. After that, single precision நம்ம split பண்ணிக்கணும். So what is the format field உங்களுக்கு தெரியும். There will be a sign bit, there will be exponential value, then mantissa is also called as fraction சொன்னேன். So from this information we have to note down. So இது வந்து positive number தான். 1460.125 is a positive number. So positive number you have to mention as 0. If it is a negative number, you have to mention as 1. Any doubt with this? So sign bit 0. E exponential enna inga? What is the exponential value? 10 that you have to mention. Good. M mantissa value. This is point kapra irukadha mantissa value. It's also called as fractional value. Just to note down this mantissa value. Then followed by we have to do biasing இல்லையா சிங்கிள் ப்ரிசிஷனா பயஸ் பண்ணாதான் நம்ம வந்து அந்த ஃபார்மேட் குள்ள அவங்க அசைன் பண்ண ஃபீல்டோட பிட்ஸ்ல நம்ம ரீப்ளேஸ் பண்ண முடியும். நவ் வி கோ ஃபார் இ complement is nothing but what is the value for what is the formula for finding biasing? E complement equal to what? E plus bias. So for single precision, what is the bias value? Students, please reply. For single precision, what is the bias value?
127.
Very good. For a double precision, what is the bias value?
1023.
Very good. So that you have 1023. Okay. Next. Now, as you know, E plus biasing, E value is 10 plus bias value is 127 equal to what value? 137. Now, how we have to simplify this value? In the exponential நம்ம simplify பண்ணாதான் அந்த ஃபார்மேட்ல கரெக்டா நம்ம பிட் வைஸா நம்ம ரெப்ரசென்ட் பண்ண முடியும். So these are the process you have to do. Very simple. Need not get confused. Any number is given to you. We have what is the question they will ask us? You have to convert this given number into its binary format and you have to convert into its single precision and double precision. இதுதான் நார்மலா கேக்குற floating point number conversions. So given any floating point, this is the procedure you have to follow. First you have to convert the given decimal number to its binary form, then you have to do the normalization process. Normalization நாவே exponential convert பண்ணிடணும். So point just front la move பண்ணிட்டு into 2 to the power 10. After that single precision, what are the value you know? You have to know. S for sign bit positive 0, E for the exponential value 10, M is a mantissa value or fraction value after point decimal. After noting that E dash is equal to E plus the bias value of a single precision 10 plus 127 137. Then after this you have to convert this 137 into its binary form. All got this value? Check பண்ணிக்கோங்க, cross check பண்ணிக்கோங்க. 137 you have to do, you have to convert to binary form. How you do? All got this answer? Like this you have to proceed. Like this you have to proceed. Okay, what answer you are getting? Are you getting this answer? All are getting this answer. 1000 1001. Please reply yes or no.
Yes, ma'am.
Alright. After that, last. So our modified exponent part is now play to its precision format. All know this is in a single one bit, 8 bit, 3 bit. Yes, already you know in bit 0. Exponent what I have to place here? Value. The bias value have to this now 8 bit. So number base that that you know from the base again a place dot dot remaining is so you have to yes.
Voice is breaking, ma'am.
Voice break. Okay, display பண்ற information சரியா?
Yes, ma'am.
Yes, okay. So again you have voice break. Now is it okay?
Students, can you hear me?
Students, kindly be in line. Can you hear me?
Yes, ma'am.
Please reply yes or no. concept and the PPT, okay? இது மட்டும் கவர் பண்ணி தண்ணிட்டு டபுள் ப்ரெசிஷன் பார்த்துட்டு I'll share the screen. The plane on can you see what is playing? Yeah.
Ma'am, your voice is breaking, ma'am.
Okay, சரி இன்னைக்கு இந்த ப்ராப்ளம் மட்டும் சால்வ் பண்ணுங்க. Voice is breaking. Hello.
Breaking only, ma'am.
Okay. Since alone you just tomorrow just in the beginning. We have converted the given E complement is being placed in the single fish form information. Fields or exponent fraction 0 for negative numberization as it is a number percentage by exponent value has here bit presentation. The normalized value and same way double number s equal to 0 in bit equal to value hash to 10 plus 5.
Ma'am,
Yes.
your voice is breaking, ma'am. I can't able to hear it clearly, ma'am.
Okay. You just tomorrow, okay? No issues. Jayesh, can you hear me now, Pa?
Yes, ma'am.
Now is it okay?
Yes, ma'am.
Hello. Okay. Today you just note down the information whatever I have covered in your computer architecture notebook. Tomorrow again I'll revise the same concept with the information with the PPT too. Okay? Floating point representation நாளைக்கு மறுபடியும் நடத்தலாம். Okay. Network issues இருக்கு காலேஜ்ல அதனால we are not able to continue. Thank you students. The Jayasuriya, can you hear me? Jayasuriya,
Yes, ma'am.
absentees name மட்டும் அனுப்பி விடுங்கப்பா please.
Absentees.
Can you find that?
Ma'am, screenshot எடுத்துக்கிறேன், ma'am.
ஏப்பா ஓகே ஸ்கிரீன்ஷாட் எடுத்துக்கோங்க இப்போ உடனே. Students kindly be in line for 2 minutes. Let your friend take the screenshot. Okay, till what we have covered, any doubts you have? Other students, please reply.
No, ma'am.
Okay.
எடுத்துக்கிட்டேன் மேம்.
Okay. Thank you, Jay Surya. Okay. Thank you, students. You can go. You can leave the
Thank
meeting. Thank you so much.
Thank you, ma'am.